A common question that comes to our mind is that since streams and collections both used to work on data or both used to work on groups of elements, how the two are different in their approach. So the difference lies in not just in their approach but in their purpose as well. And as it is clear from the word itself, one is a stream, which means a sequence of elements, and another is a collection, which means some data structure, some way to collect those elements. But if we go into more detail, we can say that collections are used to store and manipulate groups of objects in memory. So they provide the methods for adding, removing, and retrieving those elements from the collection, and also a way to iterate over those elements. While streams used to perform operations on collections or arrays of elements, they are not data structure themselves. Rather, they represent a sequence of elements that can be processed one at a time. Streams are designed to allow for functional style operations on data. And what are those functional style operations? They are filtering, mapping, reducing, sorting, and other operations available in the Stream API. They can be used to process large amounts of data efficiently by parallelizing the operations across multiple processor or threads. So, at a very basic level, we can say collections are used to store and manipulate groups of elements, while streams are used to perform functional style operations on collections or arrays of elements. An interesting metaphor related to this I found in the book Java 8 in Action, authored by Roel Gabriel Urma, Mario Fusco, and Alan McCroft, where they have compared the two by visualizing and comparing the DVDs and live streaming over the internet. And there I found this interesting graphic as well. So the authors have mentioned that consider a movie stored on a DVD. We can call that a collection of perhaps bytes or frames, whatever. Now consider watching the same video when it is being streamed over the internet. So this is now a stream of those bytes or frames. The streaming video player needs to have downloaded only a few frames in advance of where the user is watching. So you can start displaying values from the beginning of the stream before most of the values in the stream have even been computed. So the graphic tells a lot that just like inside the DVD, the entire bytes of collection is available to you, and it's up to you whether you want to forward it or whether you want to go back to the DVD. You can do it easily. But have you ever tried doing the same thing over a live stream? It won't allow you. Even if you drag your cursor to the streaming video, it will take some time to compute those bytes and to compute those frames for you. Why? Because for the lazy approach of dealing with the bytes, it will only compute as needed. So that's a very general comparison between the collection and the streams that we can make. So, in the very roughest term, in the very basic terms, we can say that the difference between collections and stream has to do with when things are computed. A collection is an in memory data structure that holds all the values the data structure currently has. Every element in the collection has to be computed before it can be added to the collection. By contrast, a stream is a conceptually fixed data structure. You can't add or remove elements from it, whose elements are computed on demand. So you can't do it in advance. Another view is that a stream is like a lazily constructed collection. Values are computed when they are asked by a consumer. In contrast, a collection is eagerly constructed, it is supplier driven. Other than these, there are other some interesting comparison points as well. Like we can compare the two on the basis of how they operate, how they traverse, and how they iterate over the data. One do external iteration, another do internal iteration. The types of operations are different. So we'll try to cover all that in the next part. And other than collections, streams are often compared with the input output stream classes as well. So we'll try to see that in the next discussion.